Hello and welcome to lesson 4.1b, right angled triangles. So first off, we're going to take a look at the relationship found in a right angled triangle. That relationship is often referred to as the Pythagorean Theorem. Now, even though it may be referred to as the Pythagorean Theorem, there is some contention as to whether or not it was actually invented by the gentleman by the name of Pythagoras and therefore attributed to his name. So it is often referred to as Pythagorean theorem, but some teachers may not refer to it as that way. First of all, the actual Pythagorean theorem states, or the relationship takes a look at the lengths of the sides given its areas creates a equal area c squared. So it actually takes a length c, squares that value, is equal to a squared plus b squared. So it actually looks at the sizes of the squares in each area. So these two areas equal up the area of this big square right here, which I'm just not able to draw it because of the size of it. Now this requires you to, if you want to solve for any value, either a, b, or c, you're going to actually have to use a square root function, which we'll practice using your calculators now. So first of all, find out where your square root function is on your calculator. And let's practice it. So the length of the base of a triangle is 3.5 meters. So I'm going to draw this. Let's say this is 3.5 meters. The length of the height is 7.1 meters. Something longer. Determine the length of the hypotenuse. And again, this relationship only works for right angled triangles. So it talks to about calculating the hypotenuse. Here we're looking for this longest edge, which I'm going to call C. So the relationship takes C squared is equal to one of the lengths squared, doesn't matter which one, and adds the length of the other side squared. Now again, using your calculator, all you have to do is calculate 7.1 squared, add 3.5 squared. So using your calculator, you should get 62.66. Now when you start calculating on opposite sides of the equal sign, you should separate them and do one step at a time. So in order to calculate C, what we need to do is we need to work out the square root of 62.66. In other words, what value times itself would equal 62.66. Now you'll find that this isn't an exact value. It works out approximately to approximately 7.916. This measurement was in meters, so this is in meters. This measurement right here would have been in meters squared. And there you get your length of your hypotenuse. Okay, let's try that again, finding a different length here. So here we're going to calculate the measure of the unknown side. This time, it's the base length. So again, the hypotenuse, square that value, equal that to one length squared plus the other length squared. In this case, I know other length is called by x. Well, I want to solve for the unknown side. So that means I'm going to have to rearrange my equation by subtracting 4.9 squared off both sides. You could square the value 4.9 first and 27.5, but you don't need to. You could do this all in one step. So if I work this out using my calculator, I get 732.24. Well, to get x by itself, I need to square root 732.24. Now if I write this in the proper format, we should actually put the x on this side, and you'll notice it turns out to be approximately 27.060, and this is measured in centimeters. Okay, let's try one other problem. So right here, you actually notice that this big triangle that we have here is actually made up of two small right angle triangles. You'll notice one right angle right here and one that's hidden right here. It wants to find the value of y. Well, in order to find the value of y, I need this length right here, and I also need this length right here. Well, you notice this length I do not actually have. I only have part of it. I know part of it is added to another part that's equaling 16.75 meters. But what I can do first is find this length x in that other triangle. So again, I'm going to set up my Pythagorean Theorem. And I'm going to solve for x. So I'm going to subtract off 5 squared. On both sides. If I calculate this, I get 144 equals x squared. So x is going to equal the square root of 144. Now this one turns out to be exactly the value of 12. So, in other words, this length right here is 16.75 minus 12, which is 4.75 meters. If you want, you could put the measurement there. So now to solve for y, we could use Pythagorean Theorem again. I know y squared is equal to 5.00 squared plus 4.75 squared. So y squared is equal to, plugging that in my calculator, I get 47.5625. To work out y, I just need to work out the square root of 47.5625. And that works out to about 6.897. And again, use the measurement, units, meters. And thus concludes this lesson on how to solve right angle triangles, lengths of right angle triangles.